Okay, so we can continue. Today it is relatively easy. Today it's relatively easy. We are going to talk about operating systems now. We are going to talk about the history of, it's chapter 3, history of operating systems, operating system architecture, of coordinating the machine activities, and multiple processes. How do we handle multiple processes running at the same time? There was a famous time-sharing video. The link is there. So we have various kinds of operating systems. Bu sebepten yapıyor. Okay, now I have to go back to let me check the OBS. OBS is recording, fine. Okay, so history of operating systems, architecture, and multiple processes, and there was a link. When we talk about operating systems, we can name a lot of different operating systems. Maybe today you have Windows, Linux, and Unix, and macOS as an example. But in the history of operating systems, we had a lot of different varieties. But basically, their purpose is always the same. File operations, coordinating file operations, scheduling applications and programs, and execution of program, coordination in execution. In the early days, people didn't have interactive computers. We had batch processing. It is like, did I told you about this? It is like olive oil extraction. You collect your olives and put it in the bags and take it to the olive oil factory. Assume that you have 250 trees and you have like a full truck of bags for you. You took the bags to the olive oil factory, fine, and you drop the bags and you wait. If you know the owner of the factory, your olives are turned into olive oil earlier. If you are not a friend of the factory owner, it takes a week. If you are the friend of the factory owner, it is done next day. So it is basically who comes first into the factory and who knows the factory guy or the worker guy better, because they can shuffle who is going to be first. And the important thing is, if you are the first guy, if you are earlier, your olive oil quality will be better, low acid, etc. Because as long as you wait more, the acidic value increases. So they take Ahmet Bey's olives, squeeze it, then take Veli Bey's olives, squeeze it, store it. So they also put marks. This is yours, blah, blah, blah kilograms of oil, whatever. Okay, they take half of it as a payment, and so not half of it. It's 1/7, 7 to 1. So every 7 liters, they take 1 liter as a processing fee. Anyway, but that's batch processing. there is no automated mechanism. They take block by block, and once you leave your job, you forget it. You drop your olives, you go back. And in up until 1960s, 1965, this was the case. There were batch systems. You were writing your programs, giving it to the operator in the computer room. If you know him or her, your program will be executed earlier. If you don't know, if you just if you are a regular person, doesn't know anybody from the computer center, you will be the last. And you will be hoping that they will be trustworthy people, they will be honest, so they will make the order without sacrificing the honesty. But if it is like a corrupt country, corrupt computer center, your job may never get done because other people will be always placed before you. So that was batch processing. In the interactive processing, that's different. You are interacting with the computer, you are writing the application, you are saying run, go, whatever, so initiate. So it is an interactive process. It is not like a leaving and going away. It is interactive. Once you do interactive, the problem is computer is so expensive. It was expensive. It is still expensive. So if a computer program thinks, writes a couple of lines, thinks again, opens the book, then writes, if that time is only allocated to the computer program and the user, it will be wasted. Assume that remember that the computers were millions of dollars each, a big room of equipment, millions of dollars, and they cannot let you think in front of the computer while the fans are running and the CPU is active, CPU is not running active, and the power is up because it consumes like 10 kilowatts of power, 10 kilowatts, 20 kilowatts of power, the typical 1960s computer room. So it's a lot of, it's like an industrial machine. So they don't let you think in front of an interactive system. So they have to introduce time sharing. Multiple people should be able to do interactively so that at the average it will be busy enough. Like if 20 people are doing something, editing, interacting, running, then on the average it will be busy enough to make it profitable. For one person, it will be not profitable and it will be a waste. Do you understand? So even today, $2,000 computer here, $2,000 computer cannot only run one single task, it runs multiple tasks. I have email open, I have OBS video recorder open here, I have the PowerPoint open. PowerPoint might have multiple processes. I have a printer, I have a browser open at the back. I have a disk process, I have an internet communication going on. So multiple things are going on at the same time. There's a charging controller process, there's a video out process. So multiple programs are running at the same time on a single computer. I don't have to have different computers for each task. I can do it with multitasking. Single computer doing multiple tasks. Furthermore, some machines have multiple processors or multiple cores. Sometimes multiple cores, sometimes multiple processors. That increases the performance because a processor, that was the question in the last week's quiz, remember? A processor has certain parts: arithmetic, logic unit, control unit, program counter, and memory, etc. So and registers. If that is not sufficient, and there are multiple people, many tasks, many programs, you may have more than one microprocessor sharing multiple programs. Let me do this way, let me do that way. Multiple processor can work. So an operating system is like a mechanic shop. There are processes, there are CPUs. So CPU is basically the mechanic guy here. And processes are the tasks which are in the mechanic shop are the cars. So here we have 3 processes and 1 CPU. The other one is, I think, customer. So 1 CPU and 3 processes. So are they being serviced? Yes. Are they being serviced at the same time? Yes. But are they being served at the same instant? No. What happens is the guy works on one car 20 minutes, another car 10 minutes, another car half an hour, and keeps rotating until they are finished. Okay? So it is multitasking. When you have 2 processors, you may have 2 2 mechanics. Then on 3 cars, on 3 tasks, you may have 2 processors, which will be faster. So some tasks are done by certain processors. And you might have, typically you will have 100 processes in a typical machine, 100, 200 today's computer. So when you have multiple cores, like 50 of the processes are handled by one core, another 50 is handled by another core. If there are some processes with higher priority than the others, those processes should be done earlier. If the police car comes in, because they are so busy, that has to be fixed earlier. So between processes, there could be priorities. One of them could be your friend, so it has to be finished earlier. Or you can think that it's a short task. It's a short task, like I will have the image, like tire change. When you have tire change, it doesn't take long. So you may say that I should get the tire changed and let the car out. It shouldn't sit inside the shop. That's a strategy. Otherwise, it will stay there until evening just to get the tire changed, because you are occupied with another car. So you have to find a mechanism to let the tire change car out earlier, even if you have an ongoing job with a more difficult repair. So there is a program component, operating system component called scheduler. Scheduler schedules which car is going to be, which process is going to be taken in first, and last, how much time is going to spend. So it organizes the mechanic guys. It organizes the CPU. Which process is going to come in, which process is going to come out, when. We call it scheduler. And obviously, if you know this guy, if you have the priority, scheduler algorithm changes. Okay? If you buy a pack of chocolate to him, right, your priority increases. And some tasks are short, so those tasks are important, shouldn't be held for a long time. They have to be finished as quickly as possible. And there are some longer tasks which may take multiple days. So when you have a long task that may take a week like this. Ne yapıyorlar? Şanzıman, motor yapıyorlar. A week. A tire change shouldn't wait for 1 week just because he arrived later than 10 minutes later than this customer. It's a 1 week job. So a tire change shouldn't wait that long. So an operating system, the scheduler guy, schedules those operations so that sometimes this guy leaves the job, goes back to the tire, finishes that, and come back. So that is what we call multitasking. And there are cars outside. I am sorry, I found these images from the internet so that the characters are not the same and the cars are not the same because they are taken from some different Google searches. But there are cars outside waiting which are not in the shop, so they are not started yet, but they are on the queue. So we say it is the waiting queue. When you click the program, for example, they are in the waiting queue. As they start, they are in the shop. Okay, so there is a waiting queue as well. So the older one, the batch processing, the olive oil issue is you get the job. There is a queue, and who knows if it is honest or just, but you assume that it is just. Then through the queue, there is an executing machine, olive oil pressing machine. Then the results come out one by one. So that is what batch processing is. So it is in order, no multitasking. And also in the olive oil process, they can't do multitasking because they cannot stop squeezing the oil of one person, leave it, and put the other pieces of the olives and squeeze like a one gallon. It is impossible. So the nature of that job, the olive oil thing, is the batch. They finish yours, they finished your neighbors, they finished the other one, they finished the other one, because olive oils are separate for each customer. They don't want them get mixed. You cannot say, they're all olive oil, what happens if I get the other person's oil? No, because you don't want it, because you made it kind of organic and you'd like to have it yours. So they are separated. So all of them are separated. In the interactive process, you have the machine domain and you have the user domain. In the user domain, there are interactive editors and shells to start, stop the program. And program execution is interactive with the users. Through the operating system, on computer hardware has an operating system on it, which is a program running all the time. Then there are some other applications connected to the operating system, which comes with the operating system itself, like utilities, etc. And users are connected. Users are using those system and applications programs individually. So this is what happens generally with the operating system today. Any questions? Şuraya oturursam diye çabucak. Sütlü kahve içeniniz var mı? Sınıfa çayla kahveyle girdiğiniz zaman unutup bardakları ayaklarınızın dibine koymayın. Alıp çıkın. Birçok toplantı salonunda içeriye yiyecekle, içecekle girmeyenin sebebi insanların yarıda bırakıp özellikle sütlü kahveyi, şekerli çayları ayaklarının dibine koyması. Daha sonra ders bittiği zaman, toplantı bittiği zaman da unutup ayağının çarpması ve onun dökülmesidir sebep. Yoksa içeride içmeyin değil. Tamam. O yüzden ne yapmamız gerekiyor? Çayımızı şekersiz, kahvemizi sütsüz içeceğiz ki devrilirse en azından lekesi çıkabiliyor, temizlenebiliyor. There are various kinds of operating systems. Five main types here are listed. Batch operating systems. Things are happened one by one. Time sharing operating systems, which does one task little bit, other one little bit, other one little. So these operating systems are time shared operating systems. macOS, Android, Windows, Unix, Linux, those are time sharing operating systems. Distributed operating system means it's a combination of multiple machines together at the same time. There used to be more. Today also, for example, the cloud operating systems are distributed operating systems. So you don't care about how many different computers are connected to it. And file sharing programs. What file sharing programs you use today to download films, music, books, PDF? What is the illegal peer-to-peer program of these years? Torrent. So torrent is, for example, a distributed operating system. It's a distributed operating system application. Sometimes it is called network operating system if there are local different operating systems are placed together to form a harmonious group. And finally, there are real-time operating systems. Real-time operating systems has deadlines. They are used in applications like in cars, in robotic controllers, where the timing is important. Timing is how important? For example, a typical car engine rotates about 4,000, let's say 3,600 revolutions per minute. 3600 devir. 3,600 revolutions per minute makes how many revolutions per second? 60. So a typical car engine, when you press the accelerator, the engine rotates 60 times a second, right? 60 times a second. So it is not a joke. At each rotation, electronic engine control unit determines how much fuel needs to be injected. It has to be computed. Today's ignition systems and injection systems are electronic and controlled by engine control unit. In the older days, what did we have? We did have carburetors, right? The carburetors are mechanical devices which mixes air and the fuel with a predetermined ratio, and there are some vacuum connections to it. So it's all mechanical, and it is basically a spray. It is spraying fuel into air. We assume that it is mixed and it is burned in the engine. With the new systems, there is an electric controlled injectors. Those injectors are opened and closed with electric pulses. And the length of those pulses determine how much fuel you give to the engine. You have to compute that amount 60 times a second before anything happens, before it is occurred. If you are late, engine keeps rotating, so it will be misfire. Engine will stall. So you have to complete the computation of how much before it comes to the correct place, and at the correct time you have to instruct this amount of fuel must be injected to the engine, and injector opens and closes. You cannot do it with Arduino. You have to do it with little more powerful computer processor, but you can do it. So they have the keyword his deadlines. You have a deadline because the engine is rotating. You have to finish computation. Otherwise, you are dead. In the robotics, robotic arm picks up something from here to here in the factory. When we talk about robots, generally it is the industrial robots. I don't know how it's going to be in future, but it's industrial robots. So the minimum frequency for industrial robot is computation frequency is 1 kilohertz. So at each second you have to make computation 1,000 times. If you go below 1,000 computations per second, then it feels vibrating. So it doesn't feel smooth in operation. So 1 kilohertz, 1,000 computation per second, and repositioning the motors is required. So you shouldn't be slower than that. And it's not like a Windows machine, because in Windows or Linux, it may take long. Sometimes it becomes slow, so there is no guarantee. But in the real-time operating systems, there has to be guarantee. There are ways to do it. It's not a magic. There are ways to do it. Basically, they are connected to the counters and timers. The presence of timers are more prominent, more visible in real-time operating systems. If you think of that constraints, you can make your operating system real-time. You can make that was wrong. You cannot make your operating real-time. You can make a real-time operating system. So from start, you cannot turn an existing operating system into real-time easily. You have to think from the beginning. The software running on those operating systems are two kinds: application software and system software. They provide application software and system software. The classification of this software is as follows from the Brookshire. It could be application software that we use. System software is of two kinds. Utilities are operating system part. Operating system part is the core. That is also divided into two. The core of the core, which is kernel, and the user interface. So operating system consists of user interface and kernel. User interface may not be graphical all the time. It could be text user interface. It is still user interface. So a user interface doesn't have to be graphical. Anything that talks to user is user interface. Okay? If you have a question, please ask. So that could be graphical, as I said, GUI, or text-based shell, which is what you have been using since the beginning of this semester. And I believe that you are almost done. You are almost good with the Linux at this time. So all of you are able to use Linux shell interface to interact with the computer. The kernel is a small application which runs on the hardware all the time. It's a continuous running application, software, not application, that's software. It basically has, it is responsible from file managing, device driving, memory management, and scheduling. These are the pieces of the kernel, the most fundamental parts. Basically, this is another vision of it. You have multiple users interacting through the user interface, and at the core you have the kernel. Kernel is an application, so it is not like a magical ball. It's an application but it is running all the time. When we have the file manager, it is basically the data stored in more stable memory, hard drive or other kind of memory. The organization of those data, organization structure, is named as folder or directory. This directory is named after this thing. In Western world, these file cabinets are very common. They have been in use for the last 150 years, maybe more. 150 years, maybe more. So that's why you have these drawers, and within those drawers you have small file binders. That's folders. These folders, and inside the folders you have documents. So the same naming, okay, same naming is presented, and these okay, where is it? These folders have raised edges like this, raised edges, so that you can put stickers and you can write on them, and as you are searching you can see what was in the folder, like here, okay, named. And sometimes those are placed in different locations, left and right, so that you can see it from one behind. You can see it. You can organize it. So the folder metaphor in computer operating systems comes from this older file folder cabinet structure, which is the office structure of past maybe 200 years. We didn't have that much folder approach in our country, but in the Western world it is so common still. That's why, oops. That's why we have the folder symbol placed like this. Çocuğun birine şey göstermişler, disket. Babasına şey demiş, baba kayıt sembolünün gerçeğini yapmışlar demiş. Kaçınız disket kullandı? Yani az. Bu da belki ileride öyle olacak. Our computers have large amount of memory, like 8 gigabytes, 16 gigabytes. This one is 16 gigabyte has 16 gigabyte of memory, and 500 gigabytes of disk drive. You have multiple applications running, and they are trying to be in certain places, and there is a system unit, hardware connected system unit, called as memory manager. Memory manager allocates space in memory for multiple programs. I have a question. Now you are comfortable with the Viz machine, right? When you write the Viz machine, do you talk about memory address in the program? Yes, you give the address of the source number, destination number. You have addresses in the program, right? Like get the number from 6E, right? And get the number from 6D and write the sum to 6F. You know that. So 60, or go to program counter, some other address. So program counter is reloaded with certain beginning of the address, right? So that you will make a loop. Are we together on that? How about two programs running at the same time? Two programs running at the same time on Viz machine, multitasking Viz machine. You have an addition program, and let's say you have a subtraction program running in parallel. You have prepared an addition program, 60 program counting, and you have a subtraction program. What is the problem here? They cannot be on the same space. Subtraction program must be somewhere else in the memory. But when you are preparing your program, did you know where it would be? No. So you say start from 00, right? Start from 00 and load the number at 60, load the number at 6E, and write the result, add them, and write the result in 6F. Are you following me? So that is your program. The other program does this similar thing, but subtraction. But if they run together, that space is the same space. They can't stay together. You have to either modify the program, meaning that go back to program, change those addresses, change the location of the program so that it will be somewhere else. That may work. Or put a mechanism that will fake each application, each program, that will fake each application as if they are using the original location. That faking says to the program, okay, you are here, but actually it is not there. The program thinks it is writing to 6D, 6F, whatever, but actually the memory location is somewhere else. For each program, that location is constant, but in reality, we don't know where it is. And that is done by memory manager. It's a chip and very highly connected with the operating system functions. It creates the illusion, that the machine has more memory than it actually does also, which is virtual memory now. And by playing a shell game in which blocks of data, pages are shifted back and forth between main memory and mass storage. So it also uses hard drive to make actual memory larger, because your code is not active all the time. Your codes, different places are not active all the time. Some places are never used. For example, in the Word, you have word art section. How many of you used word art? Not many, right? Or macro in the Word, Microsoft Word. So those parts of the code never gets run by many people. So why do I have to load it to the memory? Because I'm not going to use it. I'm not going to use that part. I'm not going to call that function. Therefore, the main memory manager keeps them in the hard drive until you use it. If there's a function call to that part, then that part is loaded into memory and you continue as if nothing has happened. So this is one of the main tasks of the operating system, memory management. Lastly, there is a bootstrapping mechanism. If you turn on a machine, computer-like machine, something happens. That thing is bootstrapping. In the read-only memory, sometimes people call it firmware, has a program, just like the Wiz machine, the starting program. When you turn on, it starts from zero. It starts from zero and tries to do certain things. That is bootloader. The bootloader loads small program that can execute the code in the master boot record of the hard drive. And the master boot record of the hard drive has small piece of code, boot, then it takes you to the operating system. The first part of the operating system runs, then the next, and the operating system boots up, and it never comes back. That is what we say boot. Up, yeah. When you turn on, in the read-only memory, there is a program. That program runs, and the function of that program that runs it the first time is to load the operating system from disk. So loading operating system from disk program is etched inside the read-only memory, so that when you turn it on, it automatically starts all the time. That loads the operating system from disk. That is what we say boot. In the ROM, there is a bootloader, and the rest of the memory is empty. And the bootloader starts and then loads the operating system. Then operating system keeps running. So reboot means pressing a button, and that button creates an interrupt. That interrupt restarts the boot process, and it means reboot. Coming back to process mechanic shop, the activity of executing a program is process. You may write a computer program. A program is a program on the hard drive. A program is a program on your notebook. On your notebook, I mean paper notebook, it's a computer program. On an exam paper, it's a computer program. But when it is running, it is process. So if it is running or it's about to run, it is process. And process state means current status of the program, process. It could be waiting, it could be running, it could be idle, etc. Relevant terms are program counter, registers, and memory. So you are very familiar with these terms because you know what a CPU is, and you know what an assembly language is, you know what an assembly program is, and you know how computer works at this time. Right? So these are all familiar terms to you. The scheduler, you have multiple processes, adds new processes to the process table and removes completed processes from process table. Dispatcher controls the allocation of time slices to the processes in the process table. The end of the time slice is signaled by an interrupt. Tuck, tuck, tuck, tuck. This, and then each time slice is signaled by a timer. This is the scheduler, another scheduler woman, and dispatcher. Dispatcher is interesting. He is in the shop floor and says, Ahmet Usta, leave that car, go here. So that is dispatcher's job. So when the computer is multitasking, it is basically doing this, leaving, doing that, leaving, doing this, leaving, doing this, leaving. So because it can't do everything at the same time. Same time means little bit of this, little bit of that, little bit of that, very fast, so that customer thinks my car is being fixed. No, it is not being fixed. It is waiting in the shop. Every 20 minutes or half an hour, the guy comes, does something, but it is not constantly being fixed. Sometimes it has an idle time. And this is what happens between process A and process B. There are time slices, and there is a switching cost. The white areas are the time when the guy is switching from one car to another car. What happens? He may smoke. He may have a tea, right, from one to another. So there is a certain time, and that time is at the beginning, in the early days, it is like 10%. 10% of the time is dedicated to switching. Today it is 2% or something. 2%, 1%. So that work, switch, work, switch, work, switch, work. So that kind of operation is done. For example, in my computer, where was it? Okay, I have 680 tasks. See the top right? My machine has been up since 62 days. I haven't rebooted for the last 2 months. And OBS is taking a lot of CPU time, as you see. And I have a web server running, which is HTTPD. And I have multiple cores. I have 6 cores, at 6 cores, 6 different cores, I have the load 17, 62, 13, 30, 12, and 83. So probably that 77 is the OBS video recording, one of the processes. And the number of processes are 563, done very frequently, so I feel that they are running concurrently. They are not running concurrently, little bit, little bit, little bit, little bit. By 6 cores, 6 tane ustam var. And 3,300 threads. Thread means smaller pieces of process, smaller part of an application, which can run independently. Her bir program neredeyse 5-6 thread'e sahip görünüyor. Thread ne, kaç kişi biliyor? Tamam. Programınız, kod yazdınız. Kodunuzu analiz ederken satır satır bakarsınız değil mi? Bir for döngüsü. Buraya geldi, buraya geldi, buraya geldi, buraya geldi. Hep şöyle bakarsınız. Siz varsınız sadece. Böyle bakarsınız. Peki 2 kişi beraber aynı koda bakın. 2 kişi beraber aynı koda baktığınızda bir kişi bir yere bakıyor, öbür kişi başka bir yere bakıyor. Aynı koda, duvardaki. O 2 kişinin düşündüğü, böyle çalışıyor, böyle çalışıyor dediği yerleri 2 ayrı kişi üzerinde çalışıyormuş gibi düşünün. O zaman 2 thread'li bir program oluyor. Bir thread aynı yerde çalışıyor, bir başkası da aynı yerde çalışıyor. Dolayısıyla tek bir parça kodunuzun 2 ayrı çalışan kısmı gibi oluyor. 2 kişi çalışıyor tek kod üzerinde. Avantajı ne? İşte birisi user interface çalışıyordur, biri network çalışıyordur. Network user interface'i beklemez, user interface network'ü beklemez. Asenkron çalışabilir. İkisi daha hızlı çalışabilir. Öyle bir avantajı var. İki kişinin bir tuvalete girmemesi lazım. So there are critical operations such as going to bathroom or using a special knife which is not shareable. Some resources are not shareable. You take it, other guy should wait for you until you finish. But taking that, grabbing the knife must be regulated. There is a knife on the wall in mechanics shop. Let's go back to mechanics shop. There is a knife or special tool. Okay, special tool. You need that. Another guy also needs that. You go there to take it, grab it. At the same time, the other guy also grabbed it. What happens? You pull each other. Who's going to take the knife? So to eliminate that problem, there must be a mechanism to solve that kind of condition, which is if somebody is approaching to the knife, just wait. If you let the other party to take it. That's one way. Siz buyurun. But that also can create, so there are mechanisms like I want, and there is a guy who is responsible for knife, who wants, I want, okay, makes an order, you are first, you are second, you are third, and then distributes the knife in order. So there are mechanisms to distribute resources. Similarly, in a crowded Bathroom is a good example. In a crowded dormitory, you only have one bathroom, for example, and many people wants to go there. So you have to develop a mechanism, because if one person is going too much and others will be in trouble, or if he or she goes in and dies inside, then the bathroom will be occupied forever. I mean, theoretically. So you have to develop a mechanism so that you take the control and you have to leave it back. If you don't leave it back, the system should take you out and make it available to other processes as soon as possible. So that is done. You are going to see it in later courses. That is going to be done through the architecture that we call semaphore. It is basically an older term coming from trains. In the train semaphore, there was a real piece of wood. In the older times, the train line between Istanbul and Ankara was only one line. And it was taking a day to go from Istanbul to Ankara. It is still taking a day, but there was only one line. So how did they manage multiple trains going in opposite directions? Because at some point they cannot share the resource. They cannot share the resource, and one of them should be out. So a semaphore is developed. Semaphore mechanism, not technology, mechanism is developed. For example, the line between Izmit and Gebze was one line. But in the Izmit inside, there are multiple lines, temporary lines for certain short distance. When you go to that short distance and start driving to Gebze from Izmit, you check the semaphore. What's the semaphore? Semaphore is a piece of wood. That was token though. Yeah, for example, this. At Izmit station, you stop, ask the guy, where is my token? The operating person on the ground gives you the token, if he has it. Then when you have the token, you start driving from Izmit to Gebze as fast as you can, whatever. When you arrive Gebze, you leave the token to the another person and you pass. Once you leave the token, the other train, because there is only one token, the other train going from Istanbul to Izmit can take that token that you gave and enter one line railway, because that single token eliminates two train going in the opposite direction on the same line. because there is only one token, and that token is either on this way, on that way. Someone will have that token. And the condition is, this is the token guy. The condition is indicated by a display called a semaphore. If it is up, you should stop. If it is down, you can go. Today it is with lights. In the older times, it was mechanic. It says whether the railroad is available to go or not. You wait. You stop and wait, and you go. With the trains in Marmaray, sometimes it waits. Probably there was a red light, and you have to wait for the red light. So typically, let's say train token stick. Sometimes they are keys. If you have the key, you can go. Sometimes it is piece of wood, and sometimes it is like this, longer stick, and has the name of the railway and the line on it. These are long because it is easy to give it to the person, to the train from the ground. In some other places, this is too much magazine. They use it in India today. This is the token. The guy holds it as the train passes, and the guy takes it by hand or with a fork device without stopping. Okay, so if he has it, he can move forward. If he doesn't, he should stop and wait for the guy. The Wikipedia says sometimes they used people as the tokens. There is a token person, gets on the train, goes this way, gets off in Izmit. The train comes from Ankara, stops, waits for that guy, token guy. If token guy boards in to the train, they can move forward to the Istanbul side, because otherwise two trains can go towards each other and they may hit each other. That is exactly the same with the operating systems, synchronization and critical regions and mutual exclusions. Whether you think it of bathrooms, trains, or knives or tools, this is quite an important issue in computing, because resources are not shared. Variables, for example, there is a variable called I. That I variable can be manipulated by multiple processes, multiple threads in a program, or multiple processes if it is shared. So who is going to access to that variable when becomes an issue, especially when you are doing parallel computation. And when you are doing that, we have a deadlock. Some drivers cannot go back. How many of you have driving license? İyi, super. But some of you cannot go back very nicely, and you hesitate to go back. You want the other side of the bridge go back. But if you are two inexperienced drivers in a bridge coming to each other, either of you couldn't go back. So you have to wait for another person to take the car back. One of the cars needs to back up. You have to have a non-shareable resource, like a bridge, like a street. You have to be in position of requesting. You are trying to do something, but that thing is blocked by another person, another process, and that process is also waiting you. So you are waiting him, he is waiting you. That is the deadlock. Typically, this train, there are two trains. This train waits the other train waits you. And there is no solution. The solution is not to go into this position at the beginning. So constantly monitoring whether there is such a possibility, and don't do it. If you do it, you have to reboot the machine. There is no other way. There are ways, but generally rebooting. So if this system is in Mars, for example, you cannot reboot it. It has to be designed so that this don't occur. Another one. There needs omelette for breakfast. Gets the oil because you need to make an omelette. But Adam says, let's make the pancake. It takes the pan. But in order to do the pancake, he needs oil. In order to do the omelette, he needs pan. She needs pan. Do you understand? So this doesn't move forward. One solution is to ask each guy or girl at the beginning, what do you need as an operating system? So Amy says, I will need olive oil and pan. And operating system should check whether olive oil and pan is free. If both are free, operating system will mark them as being asked. Busy. Then give olive oil. Then give pan after a while. So at that time, Adam will wait. So the operating system keeps Adam waiting without any resources. But if there is no deadlock protection, Adam takes the pan, Amy takes the olive oil, and they wait forever. So this is a typical deadlock issue, and operating system should solve it by design. And it's basically ordering and declaring based solutions. You declare what you need. If it is safe, you are given. If it is not safe, you wait. For example, I need to get this in order to finish my job. I get this, and the last one is used by another person. But the other person also needs something that I have. So we wait forever. These could be files, open files for writing. Should we give a break? Okay, let's give a break for 10 minutes, and we will come back at 11:05. The operating system is also responsible from security. Passwords protection, protecting files from unauthorized access, and so on. So there is an issue of insecure passwords, how to store passwords. How do you store your passwords? I don't have password manager. Because I have to remember the password of the password manager. So I write it in a piece of paper, or I write it in a file in a way that I can only understand. But in the operating systems, we can't do it. So we have to find a way to store passwords in a secure way. And the idea is we don't store the passwords. We don't store the passwords on operating systems. So how do we check whether they are correct or not? Any idea? We don't store the passwords, but yet we also check whether whether that is the password you selected at the beginning or not. Your password could be Ayşe 1234, right? So how do you check Ayşe 1234 is the correct password? Because what operating system does is they use a function to get a number from the password. For example, Ayşe 1234 generates 4567. Ayşe 1235 generates 4592 because it's a complicated function. So when you enter correct password, you end up with a certain number, big number. If that number is stored in an operating system, I can check when the user enters. I use the function to get the output number. An output number can be compared with the stored number. If they match, I say the user entered the correct password. But can I generate Ayşe 1234 from that number? No, I shouldn't. So
Change every time.
no, it doesn't change every time.
Not
Go ahead.
not reversible.
It's not reversible. Yeah, it's not reversible because it is it's an inline function. That is, what is the modulus of 17 on 10? 7, right? Modulus 10 of 17 is 7. Modulus 10 of 37 is also 7. So if you know 7, can you determine whether it was 37 or 17? No, we can't. So it's a typical simple, too much simple. It's a very simple modulus function. It's a very simple one-way function. It goes one way, but not the other way. So if you combine multiple modulus functions, polynomials together, polynomials and modulus functions together, you end up a long string, and if you store that string, you cannot come back to the password. And you have the function, so there is no way to generate the same output unless you have a very high-speed computer and you have a trial, which is called dictionary attack. You try every possible combinations until you get the output in the table. It is impossible. So the longer your password is, the longer the output string is, it becomes more difficult to the more complex the function is, like 128-bit encryption, 256-bit encryption, 500-bit encryption, is that the longer the bit encryption length is difficult to go back from hashed value to the original password. So we don't store passwords. And one of the ways to provide security is auditing. There are two ways of preventing crime. Or illegal behavior in society. You can prevent illegal behavior by force, such as in order to make people go slower in cities. What is the force method? You make speed bumps. You make speed bumps, people go slower. In order to prevent somebody to go into some rooms, you lock the room so they cannot get in. The second, you say don't go. You say go slow, but you record the video. If you go slow, you will be caught sooner or later. So somebody will know it at the latest. For example, the room might be prohibited for certain people, unlocked but prohibited, but there is a camera. If you go, auditing will find you, because all changes are recorded, all accesses are recorded. You can go in, nobody says anything, but when they are controlling later, they say, what have you been doing in the room? Because you are not allowed. You say, it wasn't locked. No problem, you are not allowed. So that is what we say auditing measures. And auditing is important because it allows people to, generally, it allows people to have more freedom, yet they obey the rules. So speed bumps are not a good measure. I mean, you cannot go fast, or locking every doors is not good. But if the door says don't use it, you should not use it. So, and that can only be enforced by auditing. Internal attacks are important. Internal attacks in operating systems are programs try to destroy other programs. Programs try to capture the operating system. That can be implemented in operating systems through privileged modes and privileged instructions. Some instructions in modern CPUs, starting from 386, Intel 386, there are privileged instructions. In mainframes, they already had it. Privileged instructions. Those privileged instructions only can be executed by the kernel. So the operating system, the hardware, has a kernel mode, user mode. Kernel mode, user mode. In the kernel mode, some instructions, some assembly instructions are possible to execute. In user mode, those instructions are not possible to execute. One of those instructions is instructions that changes the program counter, changes the timer. So those instructions are dangerous because you can jump to arbitrary spaces in the memory. So those can only be done by some special register changes and playing with the timers. can only be executed if you are in kernel mode. And the kernel mode and user mode can be differentiated by the hardware. Whoever starts first after the boot is the kernel. So they say, I am the kernel, unless it gives the program control in a user mode, it is in the kernel mode. So what operating system does is, I am the kernel, I am running. Now it is time for program to run as a dispatcher. Program to run. I switch the bit in one location, and now in user mode. User mode runs. Timer finishes, creates an interrupt. Kernel mode starts again, because interrupts interact with the kernel mode. So user mode, whatever user does, it comes back to kernel due to timer. But if user can write to timer, user may reset timer all the time, so timer never finishes and the control never comes back to kernel. A lot of attacks are from inside, so that is what viruses are. So the programs within the operating system, within the platform, the applications, can be bad behaving. And the system should have protection for applications that are running on the operating system. So operating system shouldn't trust anybody but itself. Okay, now we will be going to a programming language, C programming language. Today, around 40% of the programs written are written in Python. 20% of the programs written in C#, C++, and C. C#, C++, and C are generally the same language. A modified version of C and C++ language is and C# is Java, Java and JavaScript. They are closely related to C and C++. Some difficult parts of C and C++ are addressed, I wouldn't say solved, but addressed in Java language and JavaScript language, so people won't make mistakes. The new languages like Rust, Go, TypeScript, which is JavaScript, basically, are new languages tightly connected to libraries. The languages like Basic, Perl, and Python, and Lua are languages that are interpreted. They are not compiled. Each line is converted to assembly language during the execution. They are slower, but they are easy to write code. So today's population is focusing on easy writing of the code. Then that's what we have. We are not teaching you, and we will not be teaching you Python, because C language is taught for making you understand all languages. If you learn how to write code in C programming language, that doesn't mean that you are going to write C code for the rest of your life, but you will be able to learn anything much more easier if you know how C works, if you know how architecture works. That's why we are teaching you assembly language a little bit. So your understanding improves and you are going to do a lot of things. Let me go to the other slide. Okay, so the C programming language for some people say it is obsolete, no one is using anymore, but it is a fundamental language. It's not a different language, it's fundamental language. Knowledge of programming is incomplete without incorporation of the C language. That's what all the professors say. It continues to dominate the area of programming for various reasons, because every other language must be written in C. Every library must be written in C. People say Python is good for artificial intelligence. It's okay for day-to-day use, but the libraries of which are the most important part of Python language, libraries must be written in C language. So if you are developing something for the Python language, Python library, for the other people, it has to be C. With the increasing use of artificial intelligence in programming, I believe the notion of C programming will be like Viz machine. We are teaching you Viz machine, assembly language, but you are not going to use it. Again, we will be teaching you C language, but you are not going to use it, probably, because those parts will be handled by you using artificial intelligence. So C part of the code will be implemented by the artificial intelligence. There will be code in C, but it will be automatically generated, just like it is automatically generated for the assembly language. Assembly language is automatically generated from C language. Now today, from regular languages, verbal languages, descriptive languages, C language can be generated, or directly assembly can be generated. We don't know yet, but it's a good idea to teach C language, just like we are teaching assembly language, to understand the intrinsics, to have your vision about what's going to be possible. In real applications, in operating systems, embedded systems, graphical user interfaces, new programming platforms, libraries, Google, Firefox, compiler design, gaming, anywhere you find in military, C programming languages used. When I say C programming language, I also include C++ and C#. Possibly a little bit Java and JavaScript, because they are correlated. Leading companies are using C programming for their professional use. If you are developing low-level code for libraries, for device drivers, for operating systems, it is important. It is most preferred language for backend developers. And what we say is, if you learn C, you can learn others over the weekend. Not because it is difficult, because it is fundamental. And learning is easy. Laptopları kapatsak daha iyi olabilir. Telefonları, laptopları. So, it's easy to learn. It is fast. It is typed. Data types are known in advance. There are a lot of operators. It is flexible, libraries, and it's portable. The problem is, since it is so flexible and easy, it is easy to make mistakes. It is easy to make mistakes. That's why people don't like it. Some people don't like it, because those mistakes are hard to find. The expanded version, object-oriented version, is named C++, and the book I put as a textbook is C programming language by Kernel and Ritchie. Kernel and Ritchie are the inventors of the C programming language and Unix, so they are the inventing people. We will be going through statements, assignment expressions, and conditional expressions, and loops, and that will be it. Some file operations, input and output, it's finished. Functions, etc. These are the guys. In early times, it was the black and white pictures are that time, and color pictures are today. Kernighan and Ritchie. Typical hello world. Some languages are dependent on lines. Some languages are not. C is not. For example, you can write number include stdioh space main space curly brace space printf space curly brace. So all of them can be on the same line. We are having multiple lines for human readability for us in the C language. In Python language, for example, it is different. In Python language, location matters. One important fact with the C programming language is we have many programming languages. We have semicolons after each line sometimes, not all the time. That means end of the statement. Statement. What is statement? Do this, this is it is, that. So those are statements. Not always equality, but doing something, calling some function. Those are statements. Equalities. A equals to B, meaning A is assigned as B. And these numbers are compiler directives because it's a compiled language. This compiled language means this code needs to be translated to assembly language and executed. So assembly language, it's actually wrong to say assembly language. It has to be converted to machine code, like hexadecimal numbers, then executed. That is what we say compiling. Strings are usually delimited with double quotes, And there are special characters like \n, meaning new line. This is a borrow, this is a, not borrow, this is a legacy from typewriters, traditional typewriters, \n. Kol vardır ya daktilolarda, cırrıt diye geri gider, o \n. Carriage return \n. Şöyledir o. Çok kuvvetli basmazsanız geri gider. En sonunda dayandığında bir tık daha döner kol. O zaman tambur biraz döner bir satır. Usta daktilocular iter elleriyle bırakırlar. Aynı satırda geri gider. Hızlı yaptığın zaman gider ve döner. Tamam mı? Tıkır tıkır tıkır tıkır şakırt diye yaparsın. Hem sola gitmiş olur hem döner. Çok vurmazsan elini sadece gider. Aynı satıra bir daha yazabilirsin. Bunların adları Carriage Return Line Feed. CR, LF. New Line ikisi beraberdir çoğunlukla. Ama ayrıca Carriage Return ve Line Feed karakterleri de vardır. So, we write our program, this hello.c. We save it to the directory. We compile cc hello.c. Did you do it? Yet? Probably this week. cc hello.c. Then the output becomes a.out. A.out is an executable code. You run it from the shell and it executes. A.out contains machine code, so it runs fast. In the middle, everything can be done within an editor, which we call Integrated Development Environment, IDE. Integrated Development Environment has the compiler inside connected somewhere. It's an application, it is run by Integrated Development Environment. It also has an editor, debugger, some help functions, all right? Syntax highlighting. So all the utilities are combined and they say Integrated Development Environment. And VS Code, which I suggest, VS Code is an integrated development environment for you. Typical editors are in Unix is VI, Vim, Nano, Edit. No, Edit is not single line. Nano, Vim, and VI are typical editors from the shell. Emacs also is an editor which you can use. Since how many of you use VS Code? Okay. Are you happy with it? Did you connect Copilot? Okay. So does it work? Okay. In C language, we have something like headers. Headers mean predefined things. Predefined things so that the compiler knows. stdio, input and output functions are given in stdio. So when you include, the executable code becomes able to do it. Becomes able to do input and output by itself. If you don't include stdio, the program doesn't know how to make input and output. Therefore, these include statements are at the top of the code so that the compiler sees it and includes those libraries. Typical characters are \n, backslash itself. If you want to print backslash, it is backslash backslash. Backslash T is tab. Backslash B is go back. These are legacy from typewriters. In typewriters also there is a backspace, single backspace key. When you press that backspace, typewriter goes back one character. One character. For example, you typed an incorrect letter. You want to fix the name, for example. You want to change the name. You press backspace, backspace, backspace, backspace in typewriter, and mechanically goes back this way. You rotate up, you put some correfix, correcting fluid, wait a little bit, it dries, take it back, and type again. So that is the changing of text in a paper typewriter. There are various ways of writing the same thing to make it more comfortable. stdio.h main program. Curly brace. Curly brace is the famous curly brace of the C programming language. It indicates I am beginning, I am ending. So it's begin and end. In Pascal language, we had keywords begin, end. Begin, end, begin, end, begin, end. So C programming language said, why am I doing begin and end words? So let's use curly braces to indicate that. So begin, end. It defines the scope. I will come to that later. So instead of writing with single line, I can write hello world end. Each line is a statement, and each statement must be end with semicolon. If you forget this semicolon, you will get an error. It won't compile. You will get a compiler error. Sometimes, in some conditions, compiler doesn't give you an error because it's a logical error. Syntactically, it is correct. It works, but it doesn't work as you expect. So those are the most important errors that cause problems because compiler cannot detect it. You are not aware of it. You made a mistake. You don't see it because it looks fine, but it's an error because it functions differently than you expect. C language is relatively difficult for that. So you have to be careful, you have to be organized and awake for minimizing the mistakes. So a typical example from the book is conversion from Celsius to Fahrenheit or Fahrenheit to Celsius. Finding the Celsius from Fahrenheit. There is a formula 5/9 F minus 32. So conversion from Celsius to Fahrenheit, and I want to print this table. One Celsius is how many Fahrenheit? No, 1 Fahrenheit is minus 17 Celsius. 100 Fahrenheit is 37 degrees. Bugün 100 derece falan sıcaklık derler Amerika'da. 37'dir yani. Ve şeyde klimaları da 72'de tutun derler. Yani 72 klima derecesidir Amerikan sisteminde. 220'de kaynar su. 215-220'de su kaynar. Bunu basacağız. This is the program. So this part is the comment section. This is the comment. Comment begin, comment end. In C++, starting with the C++, we have this double forward slash is this. But there are differences. If you want to comment 5 lines with double slash, you have to have double slash at the beginning of each line. Double slash, double slash, double slash, double slash. But with this structure, slash star, star slash, anything in between is commented out. So you can comment out big paragraph of code with just 2 locations. So both of them are valid today because most compilers understand C++ and C at the same time. Today we don't have C++ compilers as different. Most of them are understanding C++ and C together. It is mixed. So the include is stdioh. Starting with main and curly brace, we declare our variables. This is a declarative language. Integer, Fahrenheit, Celsius, lower, upper, step. So you are familiar with these because you are doing lab with Arduino. You are very good. I don't have to repeat this. But these are variables. And these variables are assignment also. Lower is equal to 0. That means lower is assigned to 0. So 0 is assigned to lower. It's basically an arrow rather than equality. Then upper is 300, step is 20. Make a starting point and make a loop. While Fahrenheit is less than upper, Celsius is 5 times Fahrenheit minus 2 over 5 over 9, Fahrenheit minus 32, and print and increment. Here we have a curly brace and we have a curly brace. This curly brace and this curly brace complement each other, and vertical line must be here. It doesn't have to be, but it is better be. In Python, it has to be. In here, it is for nice reading. Any questions? So comments are important. This is the top one is the C style. The new C++ style is the bottom. In C++ style, you have to have 3 lines in here. You only need 2. If there is a big section, this one is better. Declaration is interesting topic. I declare it and then compiler reserves a memory for it. So it allocates memory. Integer, Fahrenheit, Celsius, integer, lower, upper, step. When compiler sees it, it automatically allocates certain pieces of memory in the program, not in the memory. Viz Machine'de kod yazıyorsunuz. Kodunuzu yazdınız lab'da, değil mi? Kodunuzu çalıştırmadığınız zaman memory allocation edilmiş oluyor mu? Olmuyor aslında. O bir program daha. Çalıştırdığınız zaman o aktif hale geliyor. C'den compiler bunları Fahrenheit, Celsius, lower upper allocate ediyor dediğimde şu aslında. Buna karşılık gelen memory adreslerini tanımlayıp onu programa yazıyor. Daha memory yok ortada çünkü program kağıt üzerinde. Yani compiler'da da aslında bir çalışan bir şey yok. O hala teorik aşamada. Ne zaman ki çalıştırdınız gerçek memoriye o zaman gidiyor. Anladık mı? So what's a variable? Variable means a memory location that can be changed. Type int means that the variables listed are integers. By contrast with float, that means floating point. Numbers may have a fractional part. The range of both integer and float depends on the architecture. 16-bit sometimes 32-bit, sometimes 64-bit. A floating point is typically 32-bit quantity, IEEE, which at least 6 significant digits and magnitude generally between about 10 to the minus 38 and 10 to the plus 38. IEEE 32-bit floating point number. Which is a big number. So common data types in C programming languages are integer, float, character, short, long, double. Right? Equality is taken differently in C programming language. It's an assignment. It's not equality in mathematics. I said it before. I am repeating it. Assignment is different. Lower is equal to 0 means 0 is assigned to lower. I equals j equals k equals 0 means from right to left k is equal to 0, then k made is 0, then j made 0, then I made 0, from right to left. We don't say 20 equals to step. We don't say it. We say 20, step equals to 20. So we have the while loop. While Fahrenheit is less than upper, this is less than or equal to sign. For integer values, equality testing and these tests are okay. For floating point, it is dangerous. Because floating point 5, sometimes it is 5000001. 5000000000001 is not equal to 50. Therefore, comparing two floating point numbers for equality takes attention, needs attention. Basically, you subtract each other and look at the difference. If the difference is smaller than certain value, you assume that they are equal. Otherwise, your program sometimes works, sometimes doesn't work. Mesela biri 3500'e bölün. Tamam mı? Sonucu 3500 ile çarpın. Onu da 1 ile karşılaştırın, eşit mi? Değil. Azıcık bir virgül kalacak. Matematiksel olarak aynı olması lazım. 1 bölü 3500 çarpı 3500. Ama öyle değil işte. O yüzden eğer floating point ise fractional sayılarda eşittir mi diye bakmayın şeyde. Bu birçok kişinin hata yapmasına sebep olan bir şeydir. Yanlış anlamadır yani. Floating point sayılara eşit mi diye bakılmaz. Değildir çünkü yani. Arada formüllerden geçiyor. Aynı yere gelmesi gerekiyor ama gelmiyor yani. Böyle azıcık kenarında kalıyor. So loops are indispensable part of computer applications. There are while loops, for loops, and do loops. While loop has the following structure. Check the condition. If the condition is true, do it. Go back. Check the condition again. If the condition is true, do it. If the condition is false, continue. But check the condition first. This is what while loop is. While I is less than j, I is equal to 2 times I. Increment the I. Where is the curly brace?
Single line.
It is actually single line. It's possible, but I don't like it. So this is better. For single line, it's not required, but it's a problematic writing. Although some people say it is neat, no, it is not neat because it eliminates understanding, and when you are going to add another line, you will have trouble. When you had, for example, y is equal to 2 plus 2 times y, it doesn't get executed without curly braces. So if you didn't have curly braces, you may think that this is also executing. No, it is not executing. This is in the loop. This is outside of the loop if there are no curly braces. With curly braces, you make sure that these are in the loop. So this. And while 1 equals to 1, what happens? So it goes there forever. It waits. The assembly code is basically a loop. Some variable checking against itself. The condition is true, so it's always a loop and cannot go out. In the print statements, there are garbage characters here. These are formatting. %d means decimal number. %t means tab. %d means decimal number. Decimal number, space, tab, and decimal number. But the problem is the minus sign is shifting the numbers, and they are not also right aligned. You can have them right aligned, just like a commercial listing. So in the commercial, like in Excel, numbers are aligned to the right side. You can have that. But this one, this standard D, aligns to the left. When I say %3D and 6D, that means I will allocate spaces for alignment. So 3D gives you this 3-digit space and right aligned. Space 6D. But again, minus sign is kind of awkward. Second field, 6 digits wide. And space and 3 digit. A better version is 30F 6.1F. These are floating point. Virgülden sonra kaç basamak? So 3.0f, 6.1f, 3.0f is floating point but no floating point. 6.1f, one digit after the decimal point. Where is it? Oh, I'm sorry. Here you have the left part is the same, right part is something like this. So one decimal point. One decimal point after the actual part. Percent %d, decimal integer, numbers, percent number d, width is defined, percent %f, floating point, percent number f, how wide it is, percent .2f, 2 characters after decimal point. The left part, I don't care. I don't care the left part, but two decimal point. 6.2, I do also care the left part, 6 and 2. This is 3D 6.1 F. Instead of while, here we have while. While Fahrenheit is less than upper, there was an upper bound. So for loop is a modified version of the while loop. The condition testing and increment is combined into one line, which is for loop. That has initial condition, while checking condition coming from the while, and increment condition. So we were doing it in the while loop. Now we are having it in the for loop in a structured way. Go ahead.
Should we declare that the Fahrenheit is an integer within the Fahrenheit equals 0, and what type of difference would that have, or if any?
Between this and the previous.
No. If we declare the Fahrenheit as an integer in the same sentence that we set it to 0 in the for loop, would that have a difference?
So you mean we say int here?
Yes.
You can do it. You can do it, but it's not a good practice. It's not a good practice. You can do it. Because as a function designer in C programming language, you have to declare your variables at the beginning. Otherwise, at the beginning of the scope at least. Otherwise, it becomes confusing and you will make mistakes. Remember the olive oil and the pan example? This guy needs pan and the olive oil. The other one has also pan and olive oil, but they are going to do something different. The solution was declare what you need at the beginning. Olive oil and pan. So in any kind of program, I will need this, and here is the relation between. That is how a function looks like. If you define int var here, although this is a small program, but it could be big, complicated, it becomes confusing. One of the problems is you say int var something, and var could be used anywhere else in the function without knowing that it is declared here. In that case, variable declaration is present, but that is not the variable you are looking for. That happens, for example, with the variable I. You declare variable I, for example, at, if I print far here, what do I get after here, after the for loop? I get 300. So some part of the program may think that far is still 0 because it is outside of the loop. No. When the loop exits, it is still at its final value. And Fahrenheit, in this example, is quite visible name. But names like I, J, K, those variables, index variables, are usually falsely used by mistake. They have been declared at the top, used once, and you think that they are not used. You start writing your code, but they are not 0. Their initial value is changed, and you don't know it. So you need to be careful about variables. Yeah, you will learn it by doing. For loop is basically from 0 to 10. In C language, we start from 0. We don't start from 1. In Pascal and some other languages, there's no problem starting from 1. But here we start with 0. You can, of course, start with 1. But then you have to make I is less than or equal to 10. Or less than 11. From 0 to 10, from 0 to 9 is more C-like approach. So when we are ordering people in computer science for the lunch, people don't say I am the first. They should say I am the 0th. Okay, so the first one is actually the 0th one. Because in array operations, in memory operations, index with 0 is the first one. So it's better to use 0 for the first index. This prints 10 times, not 9 times, or 11 times. If you say I is less than or equal to 10, it prints 11 times. So these boundaries are also one of the causes of the bound problems. Doing one less or one more than necessary are errors in programming, so be careful. Sometimes I use constants. For example, I is equal to 0. I can say number define 0 0. Then I can say I is equal to 0 by word. For 0, it is not meaningful. But for things like number pi, 3.14, you define it and use it as pi rather than 3.14. This is how we do it. Define lower is equal to 0, upper is equal to 300. Define step is 20. What does it provide? If I use those numbers in many places in the program and I want to change it to something else, I can only change it at the top and the rest will be automatically changed. Those are not variables, those are constants. And those constants are placed during the compilation. In the runtime, they are not variables. So I cannot do lower is equal to lower plus 1. I cannot change them. I cannot say lower is equal to lower plus 1. No, lower is always 0, because once you compile, the word lowers are replaced with 0. There are no way lower variable in the assembly machine code part. It is all 0 or 300 or 20. It is for human reading during program writing. So far is equal to lower, far is less than upper, and step. So this allows you to easy change whatever variables necessary at the top. For complex programs where you use those things in different places, that is very nice. Because usually you change 2 of them, you don't change the rest. And you believe that you changed it, but it is not. 2 of them are missing, for example. You forgot to change some numbers because, for example, 300s will be converted to 400s. You change some of the 300s to 400, but didn't see another one, so that will cause an error. But this way, you prevent those kind of errors. In C, we don't have strings. We only have characters. An array of characters are considered as strings. So basic data type is character, is a byte. So we have functions for input and output. For input, we have getchar. For output, we have putchar and getchar. Getchar works by returning a value. So the usage is C is equal to getchar. That means C takes a character from input. C becomes the input. Putchar writes out the character. Typically, a file copying example is reading a character, having a while loop, outputting the character. So reading from one file and outputting to the other file in the loop. So copying the file can be implemented. So typically, copy input to output. What is input? Keyboard. What's output? Screen. So copying this application is actually prints what you type on screen, like a typewriter. So the main program, stdio.h is included, a character, C is equal to getchar, while C is not equal to end of file, Control D, or end of the file, print that, and get the next character. Keep getting the characters until you hit the end. This means not equal to. Okay. End of file is a special character like \n. AOF is a keyword. It is defined. It says the end of the file actually. Each file has that character at the end of the file. Okay, I think this is good enough. Now, the quiz time. Teşekkür ederiz. Arkadaşlar, duyurusunu gerçi şeyden yaparız ama haftaya itibaren C dersi yapacak kulüp. Oradan aldığınız notunuzu etkileyecek. Bu sınıf ders geçme notunuzu etkileyecek. Dolayısıyla onu da katılmış olacaksınız.
Kulüp mü hocam?
Kulübün. Bilgisayar kulübünün eğitimi olacak. Bu arkadaşlar.
Sorularınızı bana yöneltebilirsiniz.
Evet. Dışarıda sorun.
Hocam bir şey sorabilir miyim? Benim bir arkadaşım Erasmus'a gitti. Erasmus'a giderken Signal Sense Systems varmış şeyde derste. Sonra numaraya dönmüş sanırım. Ya bu dersleri numara içinde yani saydırabilir miyim diye soruyor ama.
Saydırır ya.
Saydırır.
Tabii.
Sağ olun.
Bilgisayar kulübüne kendimiz mi katılıyoruz yoksa onlar mı
O arkadaşa
ders
sor.
esnasına gelecek?
Kulübe katılmanıza gerek yok. Etkinliği takip edip etkinliğe katılacağız. Kulübe de katılın, fark etmez.
Lab'da AI kullanımıyla alakalı bir şey söyleyebilir miyim?
Hocam yasak mı?
Yasaklayacağız çünkü ne öğrendiğinizi orada ölçmeye çalışıyoruz.
Hocam öyle ama biz bir şey bilmiyoruz. Hani labda bize ekstradan bir şeyler isteniyor.
Düşüneceğim onu, düşünelim. Yani herkese eşit olacak şekilde düşünelim.
Mesela geçen hafta ben hayatımda hiç görmediğim bir şeyi yapmaya çalıştım.
Ama yaptın.
Yapmaya çalıştım hocam. Şöyle bir şey oldu. Bu UNO kartı aktarmamız gerekiyormuş ya bir şey seçmek için. Ben direkt kodu yazdım şimdi hocam. Onu aktarmayı bilmiyordum ben. Hoca da söylemedi bana, 0 verdi. Direkt.
Anladım. Şeyi yüklemeyi bilmiyordun değil mi?
Evet hocam, o yukarıdan bir şey seçmek
Evde hiç
ya.
yapmadın mı?
Yapmadım işte.
Hocam biz ödevi de yapmıştık. Ödevi hatta işte şey yazıyordu ya, işte labda açıklamaya hazır olun asistanı sorduğu takdirde falan diye.
Onu E ile de yapamazdın ki.
Biz onlara falan da işte çalıştık. Yani kendimiz zaten bilmiyoruz ama sınıfa gelince onu kapsamayan sorular vardı. Biz 3 tane görevden birini yapabildik. Sonrasında hani biz dedik herhalde böyle zor ama işte bilemedik.
Şey yaparız ya. Biz de bu yeni döneme ayak uydurmaya çalışıyoruz.
Evet
Nasıl
hocam, biz de
yapacağımızı
şey olunca
bilmiyoruz.
hani ödevi çalışıyoruz ama onu kapsamayan şeyler çıkınca biz de şey olduk yani.
Hocam
nasıl
direkt
yapacağız?
serbest bırakın gitsin ya valla.
O
Herkes
zaman
yap.
da iş
Hocam
çevirmen-
veremeyiz.
şey
Hocam
yazılır.
ödevden elde ettiğimiz kazanımla labda ürün ortaya koyamazdık. Yani
Anladım.
Hocam bir de bu quiz sistemi değişse mi ya? Ben bile açıkmışım. İlk
Tamam.
sefer
Hep en sonuncu geçerli.
öyle mi? Hocam ben diğerine 100 almıştım. O geçerli olsun.
Bundan da yüz
fazla
alırsın.
olma yani.
O zaman yatmaya başlıyorsun. Geç hadi bakalım. Birbirinizden uzak oturun. Ayrılın. Şuraya geçin.
Quiz mi yapacak?
Siz de oraya geçin. Evet.
Ne kadar sürüyor hocam quiz?
10 dakika, 5 dakika. Başlasınlar sorarsın. Evet, diğerleri yok herhalde. Tamam, 5 kişiyiz. Kağıtlarınız var mı? Herkesin kağıdı var mı?
A4 fazla mı?
Yarım A4 de olur. Yarım olur. Yarım A4 de olur. 1 A4 de olur. Bölün ikiye onu, yarım yarım kullanın. Ha.
Hocam ne soracaksınız?
Onu soracağım.
Hocam şimdi çıkayım diye dua ediyordum. İleride bir daha çıkayım diye dua edeyim yani.
Ya hocam vallahi
Evet.
Odadan gönderdim ders seçimlerini.
Hı?
Ders seçimlerini odadan gönderdim, bir hafta oldu. Ama
Tamam.
doğru gönderdim mi yanlış.
Onayladım ben odaları. Onaylanmamış mı?
Benimki onaylanmadı hocam. Perşembe ya da çarşamba günü göndermiş olmam lazım.
Şu şeyi kaydı durdurayım da yavaşlatıyor makine. Arada şifrelerime baktım. Şifreler de şeye girdi.